Hello, this is not your chem tutor, and this is part 3 of my series about reaction stoichiometry. But before you continue this video, make sure you have watched part 2, where I talked about identifying limiting and excess reactants. You will need that to understand part 3. And in this video, I will teach you how to determine the theoretical yield of a reaction. As usual, I have examples so you can practice the calculations. Of course, we start with a definition of theoretical yield. It is the maximum amount of product that is produced in a reaction. So take note of the word maximum. This means that ideally, you cannot go beyond or you cannot produce an amount of product more than the theoretical yield. Because again, theoretical yield is the maximum amount of product. And theoretical yield depends on the amount of limiting reactant. Now, why is this so? Remember in part 2, I told you that limiting reactant is the one that is completely consumed in a reaction. So what happens when a limiting reactant is totally used up? Of course, the reaction will stop. Therefore, the limiting reactant will dictate the amount of product that is produced in a reaction. So the limiting reactant will dictate the theoretical yield. Let's go back to example 1. Upon reaction of 5 grams of carbon and 10 grams of Fe2O3, we have 4 sub-questions A, B, C, and D. And in part 2, we already answered A. We identified that the limiting reactant is Fe2O3 and the excess reactant is carbon. In this video, we will answer part B. Determine the theoretical yield of Fe in the reaction. We already did the calculations in part 2, where we converted each amount of reactant to grams of Fe. So we figured out that 5 grams of carbon produces 31 grams of Fe and 10 grams of Fe2O3 produces 6.99 grams of Fe. Then I told you that the limiting reactant is the reactant that produces the smaller amount of product. So we figured out that the limiting reactant is Fe2O3. Now remember what I told you just a while ago, that the theoretical yield depends on the amount of limiting reactant. Or in other words, theoretical yield is the amount of product formed by the limiting reactant. And since our limiting reactant is Fe2O3, the theoretical yield is this one, 6.99 grams of Fe. So the answer to part B, the theoretical yield is 6.99 grams.